Hello, welcome. My name is Jan and I would like to introduce you to the topic of data preprocessing. Quite often we talk about machine learning and algorithm selection, but every model is only as good as the data we feed in. Sometimes we can even say that 80% of success comes from data and only 20% of success comes from algorithm choice. Therefore, we should put a lot of attention into data preprocessing so we can produce clean data, which will be very beneficial for our next steps of the pipeline. In this slide, I would like to introduce you the data processing workflow we will cover in this presentation. Firstly, we begin with data import and selection. After this, we will explain how to prepare data. Then we will touch exploratory data analysis. And finally, we will prepare data sets for models. Section 1, data import and selection. In beginning, we need to be able to import data to Python. There are different types of flat files and different formats. Most common we can meet CSV files, Excel or JSON. In order to import CSV, we can use pandas method read CSV, where we specify file name and import into data frame. If we are importing Excel file, we are using different method called read Excel, where we specify file name as well as name of the sheet. Many times the data is stored in database, and there are different database providers. It can be Microsoft, Oracle, Vertica, Postgres. But in this case, we will be showing example of two databases, Postgres and Microsoft. In order to connect to database, we need to use special package that will establish connection based on the credentials we have. For Postgres, we are using quite often PsychoPG2 package. For Microsoft, we have PyODBC, but there are as well as other options. You can check documentations on the links provided, and we will show in practical sessions how to use it. Especially in databases, we have data in different tables, but also we can have data in different flat files, and we want to be able to combine into a single data frame. In order to be able to do this, we need to have unique keys or identifiers in both tables. In the main table, we call it primary key, and in the table we are joining, we have foreign key. And based on those two keys, we are able to combine information. It is essential to know that there are different types of join, and we need to choose the correct one based on what we need. Very often we will be using left join, which keeps all the information from the left table and merge corresponding records from the right table. However, sometimes we might use inner join, which keeps only matching records from both tables. So it depends on what we need, and we will see examples in practical sessions so you can better understand. Once we import and join tables, we might proceed to data selection and cleaning. In data selection, we talk about subsetting section of data we need. Maybe we have in database 10 years of data, but for our analysis we need only 2 years. Another step is filtering, which means selecting only the fields and columns we need. Let's say we have 20 different columns about clients, but maybe we only need age and income for our analysis. Therefore, we select only those columns. Another step is data cleaning and validation. In here, we need to be sure we handle properly missing values, and we might think about replacing missing values by 0 or by average values, or we might need to completely remove missing values from our database. Another step is to validate whether we have correct data ranges. Let's say we have columns about client's age, and maybe we expect values only between 0 and 110, but if we will see in database values like 200, 500, we can see it's probably a mistake and we need to fix this. Also, we need to ensure we have proper column names and data types, and in the end we should remove duplicates from our table. After this, we can move to section 2, data preparation. We need to be sure we convert our data into proper types, and we have 4 important data types. We have datetime, which is useful for manipulation with datetime format. In order to use this, we need to convert input string into datetime field using method toDatetime, where we specify the column name, and also we need to be sure we specify correct format of the input, which is combination of year, month, and date. Another types that allow us to perform mathematical operations are integer and float. Integer is whole number and float is decimal number. To use this, we are using method astype, integer or float. The data type we are using for text is called string, and it allows us to perform specific operation with the text. For example, converting to uppercase, lowercase, selecting specific letters or part of the text. Another step of the pipeline is data transformation. If we talk about numerical data, we may adjust data scale using normalization by either scaling to min-max range. For example, we can scale field to range from 0 to 1, or we can apply standard scaling, where we subtract mean and divide by standard deviation, by which we create standard distribution with mean value 0 and unit variance. For categorical variables, we apply encoding, and we need to be sure to apply correct encoding. If we have nominal categories without any logical order, we can apply one-hot encoding, but if we have logical order in categories, we apply label encoding. Once we finish this, we can move to exploratory data analysis. One example of data analysis is signal decomposition, which is useful especially for time series analytics. Time series data tends to be noisy, and those methods can help us to extract patterns from the data. We have 2 methods called Fourier transform and wavelet transform that can help us better understand different frequencies of the time series. And then we have method called HP filter that help us to decompose time series into long-term trend and cyclical component based on parameter lambda. Another example of data analysis is correlation analysis. It helps us to understand relationship between different features. To do this, we calculate correlation coefficient with values from -1 to 1. Values close to 1 indicate positive correlation, which means that if one feature value increase, we expect the second also increase. On the other hand, we might have negative correlation, which means opposite relationship, and also we might have no correlation. This will give us first insight about different features and about the relationship between those, which can help us to select data for modeling. Another method called clustering can help us group data into different categories. And we need to distinguish 2 types of clustering. We have hard clustering, and the most famous method is k-means that assign each data point, specifically into one cluster. Another method is called fuzzy clustering that allow each point to be assigned to multiple clusters with different value of membership. Finally, we can move to modeling preparation. In case of imbalanced data, we may need to think about sampling. Let's say we have 2 classes, and one class has only 1% of data and the second one has 99%. And if we predict this minority class, it's quite difficult for the model and it can create bias. To overcome this, we have 2 methods. One is oversampling, which increases the proportion of the minority class. And the most common example are smooth or Adasin. On the other hand, we can fix this issue by undersampling, which means reducing number of records from the majority class. In the picture in the right, we can see example of oversampling using ADOSIM, which is trying to generate new records that will be similar to original one, but expand the number. Another technique we might apply into numerical features, it's called binning, which allow us to split numerical feature into different bins or categories. Let's say we have feature age and we want to split based on age into categories 0 to 10, 10 to 20, 20 to 30. And we have different types of binning. We can bin into equal lengths, which means that each bin will have 10 years. We can also bin based on equal frequency. So we will design bins, so in each will be, for example, 500 people. And then we can also define custom binning. For example, 0 for 18 for very young people, 18 to 35 for adults, 35 to 50 for middle-aged people, and 50 plus for older people. Before we start with modeling, we need to split data into parts that will be used for model training and model evaluation to be able to assess quality and performance of our models. So let me cover different data splits we might have for modeling. First approach, and its mistake, is to use the same data set for training and also for model evaluation. This is wrong because in this case we overfit on the training data set and we don't see how the model generalizes on unseen dataset. Another option, which is better, is to split into training and testing dataset. In this case, we allocate training dataset for fitting of model parameters and evaluate model on testing dataset. And the best option is option C, where we have three datasets, training, validation, and testing, which is especially useful for testing multiple algorithms and tuning of hyperparameters. In this case, we are testing different hyperparameters on the validation dataset, and then we evaluate only the top configuration on the testing dataset. In this session, we covered all the steps from data import and selection to data preparation, data analysis, and finally preparing of sets for modeling. Thank you for the attention and see you in the practice session.